Hello everyone, I am Uveshwar. Today we are discussing about class 11 physics chapter number 3. In this chapter we will discussing about the exercise. So first of all, our first example is that in which of the following example of the motion can be body be considered approximately a point object. So see here, there are the four options are there. So first one is the railway carry moving about jerk between two stations, a monkey sitting on the top of man cycling smoothing on circle track, a spinning cricket ball that the turns sharply on the hitting the ground, and also the a tumbling break that the supply of the edge of table. So in A and B, object can be considered as a point object because of because because of the dimension of the object can be neglected as compared to distance covered by it. Now second, the condition is not allowing C, and the D is not cannot be considered as a point object. So see here, now second is that the instantaneous speed is always equals to the magnitude of instantaneous velocity. Why? The velocity of particle at a particular instant is called the instantaneous velocity. If we talk a smaller interval of time, then value of displacement will be equals to the path length, and hence the instantaneous velocity and instantaneous speed will be equals to. Now see here, look at the graph A to D figure 3. Look at the graph figure carefully at the say the reason which of this cannot possibly represent the one dimensional motion of particle. So see here, there are the see the A to D figure gives the carefully state the reason which of this cannot possible represent one dimensional motion of particles. So in this, hence none of the graph doesn't represent the direction of motion in a one direction. There are the two directions motions, so two positions are there same at same times, and it is not for a motion in a one dimensional. B, there are a positive and negative values of velocity for the same time. It is not possible for a motion in one direction. Also the negative value of speed is not possible because it always positive, hence it is not for a motion in a one dimension in this direction. And this D is that the path length cannot be decreased with respect to time during the motion, and it is also not for a motion in a one dimension. Now see here, the figure shows that the x versus t plot of the one dimensional motion of particle is correct to say from the graph that the particle moves in a straight line for a t less than 0, and the periodic path for t is greater than 0. If not suggested the suitable physical contents for this graph. So no, we cannot say that the particles move on a straight line for t less than 0 and moves on the parabolic path for x greater than t, because of graph x versus t does not show the path of motions from graph. If t is equals to 0, then x is equals to also 0. So now reference is that for an object falling up freely from the top of tower, if x equals to 0, then t is equals to 0. Now see here, figure gives the x versus t plot of the particles in one dimensional motion. Three different equal interval of time are shown, in which the interval is average speed greatest and in which it is the least. Give the sign of average velocity for each interval. So see here, first one is the, we know that the slope of x versus t graph gives the value of average velocity, hence three graph of same time interval are shown. So velocity in the third interval is maximum, okay, because of its slope is greater. Then after, the velocity in the second interval is minimum because the slope is smaller, and velocity 1 and 2 intervals are positive and third interval is negative because in the first and second interval is slope in positive and third interval in the slope in negative. Now see here, the 2 marks examples are there. A jet airplane traveling at the speed of 500 kilometers per hour ejected its product of the combustion at the speed of 1500 km per hour relative for the jet plane. What is the speed of the latter with respect to an observer on the ground? So here Vg and the V0 are the velocity of jet plane, combustion product eject and the observer on ground respectively. Suppose jet plane is moving in a x-axis, eject combustion product are in minus x-axis. So now V of jet is equals to 500 kilometer per hour, and v zero is equals to at rest time. So v velocity of at jet plane vj minus v0, it is equals to 500 minus 0, so we will get that the 500 kilometer per hour. So velocity of combustion product with respect to time jet plane, the vg minus vj, it is equals to minus 1500 kilometers. So vg is equals to 15 minus v minus vg minus v0, so 15 minus 1500, so we will get that the minus 100 kilometers per hour. So velocity of the ejected combustion produced by the observer on ground in a opposite to jet plane is 100 sorry 1000 kilometer per hours. So these are basic phenomena. Now explain the clearly with the example of the distinction between the magnitude of the displacement, sometimes called the distance over interval of time, and the total length of the path covered by a particle over the same interval. B is that the magnitude over average velocity over interval of time, and the average speed over the same interval. Average speed of particle over an interval of time is defined as the total path length is divided by the time interval. So both A and B, that the second quality is either greater than or equal to first. When is the equality sign true? For the simplicity, consider one dimensional motion only. So see here, the displacement is shorter than. So see here, displacement is shorter distance between final position and initial position for moving object. The path length is total distance traveled by an object. So suppose object goes from B to A in time t, displacement is AB and the path length is equals to AB. So displacement is equals to path length. Now if the object goes from A to B and then C, the displacement is AC, it is equals to AB minus BC, and the path length is AB plus BC. So displacement is less than path length and the average velocity AC upon T, and the also average speed AB plus BC upon T. So thus the average velocity less than average speed. Now see here, figure shows that the time graph and of particle in motion along the constant direction. Three equal intervals of the time are shown, in which interval is the average acceleration greatest in the magnitude, in which interval is the average speed greatest. Choosing the positive direction as the constant direction of motion give the sign of V and A in the three intervals that are the acceleration at the point A, B, C and D. So see in this graph, so average acceleration is the change in speed divided by time. So now the smaller interval of time v versus t graph, see there is the v versus t graph. So slope gives the average acceleration. In the second part the slope is maximum, hence the acceleration is maximum more than part 1 and 3. Now the average speed is maximum in a third part where a is equals to 0 and v is greater than 0. So and the in first part slope is positive. See here, in first part slope is positive, hence a and v both are positive, so is greater than 0, v is greater than 0. In second part the slope is negative. See there are the second part as a slope is negative, though, so hence is the a is negative and speed is positive. So here a less than 0, v greater than 0, and speed is positive and a is 0 in third part of graph. So and the acceleration will be 0 at point a, b, c, d, okay, in graph. Now our example number 9 is that a 3 wheeler start from rest accelerated uniformly with 1 meter per seconds on a straight line roads for 10 seconds, then the moves with the uniform velocity. Plot the distance covered by the vehicle during the nth seconds. N is equals to 1 2 3 versus n. What do you expect this plot to be during accelerated motion in a straight line of a parabola? So see here, the initial velocity u is equals to 0 meter per second, acceleration a is equals to 1 meter per second square, time t is equals to 10 second, distance covered in an nth seconds. So we can get that the Sn is equals to a plus u, Sn is equals to u plus a by 2 to n minus 1. So where t is equals to n, so Sn is equals to a by u is equals to, so Sn it is equals to a by 2 to n minus 1. So we will get that the n is equals to 1 on that time 0.5 meter, Sn is equals to 2 on that time 1.5 meters, and also Sn3. So respectively we get that the value of n2 up to n is equals to Sn S10. So S versus T graph will be AB in a straight line. Okay, it is linearly increase the voltage. Okay, see here accelerated is A. So distance covered in a nth second, Sn is equals to a u is equals to a by 2 to n minus 1, where t is equals to n. So for 1 2 3 4 5 seconds, so we will get that the answer is that. So you here we put the u, it is equals to 0 on that time, we will get that the straight line answers. Now see in this graph 1 2 3 4 5 6 7 8 9 for that. Now see here, a body standing or stationary lift open the above throw a ball upward with the maximum initial speed he can equal to 49 meter per seconds. How much time does the ball takes to return to these hands if the lift start moving up with the uniform speed of 5 meter per seconds, and the boy again throw the ball up with the maximum speed he can how long goes to the ball take to the return to his hands? So first one, case one is when lift is stationary, the ball thrown by the body with the maximum velocity 49 meter per seconds come back to boy after reaching initial velocity. So initial velocity is u is equals to 49 meter per second, and 8 is equals to z, so it is equals to minus 9 into meter per second square. So t is equals to, we have t, and s is equals to 0 meter. So third equation of motion, s is equals to u into t 1/2 at square. So we will get that the s is equals to 0. So 49 into u, it is equals to our velocity, initial velocity. So v u it is u is equals to our v0. So it is equals to 49 into t into 1/2 into minus 9.8 into t square. So we will get that the t is equals to 10 seconds. Okay, so now second method is that suppose time taken to reach maximum height is t from the first equation of motion. So v it is u it is equals to v it is equals to u plus at. So we our for initial position is the 0, v0 is equals to 0. So it is equals to 49 plus minus 9.8 into t. So we will get that the t is equals to 49 by 9.8 is equals to 5 seconds. So time taken to reach maximum height, it is equals to time taken to return to back, it is equals to 5 into 5 seconds, it is equals to t. So total time taken, it is equals to t, it is equals to 2 into t. So 2 multiplied by 5, it is equals to 10 seconds. So when lift moves upward with the constant speed, in this case when the lift moves upward with the constant speed 5 meter per second, then the relative velocity of ball will be 49 per meter square, and ball will be returned back in the 10 seconds.